So, on what day was that? Last week, on Tuesday, I believe it was. It was before we took a break and did a review assignment and took a quiz. Before that, we talked about adding and subtracting when we already had common denominators, right? And once you have common denominators, the denominator stays the same. You add or subtract the numerator, okay? And then after that quiz on Friday, we talked about how you would find common denominators, the LCD. That's the worksheet we just went over. Now we're taking both of those ideas and we're putting it together. So we're going to first find the common denominators, and then we're going to add or subtract the rational expressions, okay? So here is number 1. We're calling it letter A.
So I'm guessing you can't just go across.
You cannot just go across because these are not common denominators. You can only add or subtract when you have common denominators. So let's talk about what our LCD is going to be.
A.
So it needs to have an A. It also needs to have what?
A plus 1.
A plus 1. So my goal is to get every denominator to have an A times A plus 1. Okay? So look at our first rational expression. What is this missing?
A plus 1.
The A plus 1 part. So as long as you multiply the top and the bottom by the same thing, you haven't changed the value of that expression. So I'm going to multiply the top by A plus 1 and the bottom by A plus 1. Okay? Now, I am not going to distribute on the denominator. I am going to distribute on the numerator. So I have 2 binomials, so I'm going to double distribute. A times A is A squared. A times 1A is plus 1A. 1 times A is plus 1A. And then 1 times 1 is plus 1. Any questions where all those numbers are coming from?
No.
All right. Then I'm going to have a minus. Keep it a minus for now. We'll deal with that in a minute. All right. What is my second expression missing?
A.
The A. So I'm going to have times A on the bottom times A on the top. What is A times A?
A squared.
A squared. Good. All right. Now I am going to go ahead and put these guys together. So do you see how the denominators are the same now? When the denominators are the same, you can add or subtract the numerators. In this case, we're subtracting, right? So I have A squared. I'm going to put these together right now. 2A plus 2A plus 1, and then the minus A squared. Now we can combine like terms. What are my like terms? A squared minus A squared, which gives me no A squareds, right? 0 A squared, so you don't need to write it. But I do have 2A plus 1 over A times A plus 1. Can I somehow factor these so that anything will simplify?
Yes. The top?
The top, there's no common factors of 2A and 1. Like, it looks like you almost can, because it's like, here's an A plus 1 and here's an A plus 1, but this one has the 2 stuck to it. You see what I'm saying? So this actually, nothing is going to simplify. Once you get to the point where nothing simplifies, you can go ahead and just distribute to get rid of all your parentheses. So my final answer here is 2A plus 1 over A squared plus A. I don't distribute the denominator until the very end, because if something was going to simplify, that's how I would want it to be written. I would want it to already be in factored form. That's why I'm not going to distribute and then factor. You're just going in circles. On the numerator, though, you have to distribute so that you can combine like terms and then maybe factor again. So that's why we do it on the top but not necessarily on the bottom until the very end. Questions on A? All right, here is B. All right. Any ideas what we need to do first?
Difference of two squares.
What were you going to say?
The same thing or like you have to turn I can't think of what it's actually called, but like where you turn the second one into two parentheses and divide it up.
Factor. Good. So you both want to factor the difference of two squares. So I can do that. So this is going to be this and this. All right, works for me. What else can I do?
You have to factor out the 2y minus 4.
Yeah, you can factor a 2 out, so it'd be y plus 2.
Couldn't you like cross out the 8 and make it a 4 and take out the 2?
Across a plus sign?
Yeah, right.
No, if this was a multiplication symbol, you could do that, but not with a plus sign, no.
Wouldn't that be minus? Divided by negative 2.
What?
Wouldn't that be minus unless we divided by negative because it'd be y minus 2?
Yeah.
Okay, so you want to rewrite this one as a y minus 2?
No, the other one.
The other one.
Oh yeah, you put plus 2 instead of minus 2.
But I think that'd be easier
No,
if
it
we kept
has
it that
to
way,
be
so we
plus
just
2.
need to change it to
Yeah.
negative.
better.
I'm confused.
So yes, okay, so I just wrote it wrong. I copied it down wrong. Okay, yes, I agree. So it was a minus sign, it should still be a minus sign.
Mm-hmm.
I am sorry. And then this guy should not be, well, should this guy be crossed out?
No.
Yeah.
No.
If we divided
We can make that a negative 2 and then change it to y minus 2 or y plus 2. So then you can cross the other one.
Gotta turn it into negative 2 plus y and cross out the 2y.
Well, we're not going to cross it out. The crossing out happens when you're multiplying or dividing and you have the same thing numerator or denominator. That's not our goal here. Our goal is to get these to match so that we can get common denominators. Do they match right now?
No.
No. What do I need to do to get them to match?
You can change the 2 to a negative 2 so
Divide by
that it's
negative 1.
y plus 2.
Like that?
On the factored one, the one that we fixed. Because that one was 2.
Yeah, she made it like if you take negative 2 out.
Instead it'd be y plus 2, which would match 2 plus y on the other one, which means that'd match. So then on this side you only have to do 2 minus y, and on that side you only have to do times 2.
Okay, so you want to do 2 minus, keep this 2 minus y,
Yeah.
right? Okay, so instead, you want to make this a negative,
Yes.
this a negative, this a positive.
Yes.
I can get on board with that.
So it matches. And then you find the least common denominator, which would be,
Okay, so hold on. I'm going to rewrite this so that they are in the same form, so now everyone can. Okay, so this, I factored out a negative. So in doing that, now these two are the same.
yes.
Okay.
Now the least common denominator for it would just be
I'm going to move this over a little bit. Shrink it. All right, does everyone see what we're doing? And there are other ways to do it. I was going to change the second denominator to be a negative instead of the first. But this is completely fine too, okay? Just remember that each piece needs to be represented in your LCD. Because we can multiply the denominators by new fractions as long as we multiply the top by the new fraction as well. What we cannot do is take pieces away. So like there's no way I'm going to get rid of this -2. The only way I can have them match is if I add a -2 back here by multiplying top and bottom by -2. Does that make sense? Everybody with me? Okay. So up front, what is our denominator missing? It has the -2. It has the 2 minus y. What's it missing?
2 plus y.
2 plus y over 2 plus y. Good. In the back, what is it missing? The -2. So I'm going to multiply this one by -2 times -2. All right, so up front, I have 2y plus y squared. I am distributing the y to both terms. In my denominator, I have -2 times 2 minus y times 2 plus y. Plus, this gives me -16 over -2 times 2 minus y times 2 plus y. Everybody's still here. Everybody's still listening. All right, so I'm going to write them in descending order. So y squared plus 2y minus 16 all over -2 times this guy times the 2 plus y. All right, is there any way to multiply to get a -16 but add to get a 2? Can I factor the top? The ways to make a 16 are 1 and 16, 2 and 8, 4 and 4. So that one is locked in, right? So y squared plus 2y minus 16. Now you just need to multiply out the bottom. I'm going to do these two first because I know this is a difference of squares. I'll get 4 and then minus 2y. Or sorry, minus y squared. And now you can distribute the -2. So y squared plus 2y minus 16 over, it's going to be -8 plus 2y squared. Wow, lots happening there. Any questions? Honestly, I would probably write one more step if I had some room. I'd put 2y squared minus 8. We just usually put it from highest exponent to lowest exponent, but wow, that was a fun one. That took way longer than I had anticipated. Everybody still with me? You awake? You listening? All right, let's move on. Good one. Good work, team. Next. It's not too bad.
How many of these do you have? I'm so confused on this.
This one?
No, no.
Oh, I was like, this literally just popped up. Okay, first of all, I want to think of all of these as fractions. So I'm going to put that one over 1. All right, what's my LCD?
1 or x minus 2.
Yeah, just 1 times x minus 2, which is just x minus 2, right? So the only one that's having a problem right now is this guy up front. So I'm going to multiply the top and bottom by x minus 2. When I distribute, I get x squared minus 2x over x minus 2 minus 3x minus 1 over x minus 2 plus 5 over x minus 2. All right, do I have common denominators? Yes, so I'm going to write this as one big rational expression. Careful that you are subtracting each of the terms in the expression that follows the minus sign. If you are struggling, put it in parentheses to see that you are distributing the minus, kind of like multiplying through by a -1. So I have x squared minus 2x minus 3x minus a -1, which is plus 1, and then plus 5. I'm just writing it all together, then I'll go through and combine my like terms. Does anything combine with the x squared? No. Does anything combine with the -2x?
Yes.
Yes. What is it?
Negative 3x.
-3x. What's -2x minus 3x?
5.
-5x. Plus 1 plus 5. Which is plus 6 over x minus 2. Okay, the top is looking a little promising. Anyone have any ideas of what's happening up there?
Is it MA?
This is an MA.
So it will be -3 and +2.
Careful.
-3 and -2.
-3 minus 2 all over x minus 2. Okay.
Let's simplify. Do we?
Yep. That is my answer. Any questions? So that's why we don't distribute if we can. We couldn't in this one anyway. But why we keep it in factored form until the end, because sometimes you can factor the numerator after you combine like terms, and then things will simplify. It's just nice when that happens. Questions? All right, part D. N over n plus 3 plus n plus 9 over n squared plus 8n plus 15. What shall I do?
We factored it
Yeah, we first need to see like what is going to make up our LCD. So we need to see what makes up this guy back here. The way we do that is to factor it. What multiplies to 15 and adds to 8?
in. 3 and 5.
So n plus 3 and n plus 5. So what's my LCD gonna be?
N plus 5.
N plus 3, n plus 5. Are either of the expressions missing something?
Yes. 9 plus
The front
5.
expression.
Yeah, the first expression is missing which piece of the LCD?
N plus 5.
The n plus 5. So I'm going to multiply by n plus 5 over n plus 5. Everyone with me? So I'm going to distribute the n. N times n is n squared. N times 5 is 5n. All over n plus 3 times n plus 5. Plus n plus 9 over n plus 3 times n plus 5. Bless you. All right. Do I have common denominators? Check. Let's go ahead and add these. So I have n squared. If you want to combine like terms at the same time, you can. Like, do you see how I'm about to write 5n plus 1n? Do you see that? How after n squared I would write 5n plus 1n? What's 5n plus 1n? 6n. So if you want to go right to like plus 6n, you can. That's fine. I'm just trying to show every single step. So if you can, kind of skip a step, that's fine, but just make sure you don't lose track of anything, okay? Do we have a factorable trinomial?
I feel if we with the end of anything, we're looking at simplify with the end of anything.
Yeah, what multiplies to 9 but adds to 6? 3 and 3. So I could write this as n plus 3 over n plus 3 n plus 5. Do you see that? All right, what's happening? Boom, boom. Questions? Mm-hmm. All right. Part E. All right, what's happening in my first denominator? Yeah, this is an MA. We got to factor it so we can see the different factors involved. So multiplies to negative 5 adds to 4.
Negative 1 and 5.
So x minus 1 and x plus 5. That works. So what's my LCD?
X minus 1.
Good. All right, so what's the guy in the back missing? The x plus 5. All right, so right now I have no changes in the first rational expression, right? That one already had both parts of the common denominator. He was good to go. Minus, what is 1 times x? What is 1 times plus 5? Plus 5, good. And then all over that common denominator. Now, you really could have probably taken care of this next step while doing what we just did. But I want to go real slow just to remind you of how important this is. If you are subtracting the entire expression, you are subtracting each of those terms. So when I make this one rational expression, it's going to be 6 minus x minus 5. Does everybody see that? Okay? All over that common denominator. All right, now you can go ahead and combine like terms. What's happening up top?
1 minus
You get 1 minus x, right? Because we have 6 minus 5. The 6 and the 5 are like terms. Everybody see that? This guy and this guy. Okay? Interesting. Yeah, if I take out a -1 on the top, I am left with -1 plus x, which is the exact same thing as what? X minus 1. Everybody see that? Boom, boom. So I am left with -1 on the top and then x plus 5 on the bottom. All right, here's F. So, what is going on? Any thoughts? Yeah, we can do MA in the back. So what multiplies to -6 and adds to -1? So x minus 3. Oops, these are y's. Y minus 3, y plus 2. Okay. So what's my LCD going to be? Y minus 3 times y plus 2. Thank you.
You're welcome.
All right. What do I do next?
You multiply y over, or 3 over y minus 3 by y plus 2.
By y plus 2 over y plus 2. Good. So my first rational expression is missing the y plus 2 part. So I'm going to have 3y plus 6 over, and now I have the common denominator here. Do I have the common denominator in the back? Do I need to multiply by something? What is it? What's going on in the back? Nothing, right? We already have the common denominator. So we are good to go. All right, if you want to write this out as one long rational expression and then combine like terms, you can. Usually when there's only like one or two, places where you're actually adding, I kind of do it at the same time. Do you guys feel comfortable adding these two right now?
Yeah.
Okay, so that would be 5y plus 6 over this, my common denominator. Okay, 5y plus 6. Does that factor?
No.
It does not. So I am going to go ahead and just multiply the bottom back out. Do you remember what it was before we factored it? What was it? Yeah, so if you started with this, y squared minus y minus 6, and you factored it to get your common denominator, when you multiply it back out, you should still end up with this, or you factored it wrong. So if I double check, off to the side, it's y squared plus 2y minus 3y minus 6, which does take us right back there, okay? So it's kind of a shortcut. If you know what you started with before you factored, when you double distribute, that's what you should get. Yes, ma'am. Sure. Any other questions on this one? All right. What's happening here?
Difference of two squares.
Yeah, we have a difference of two squares in the front, so I'm going to write this as r plus 4, r minus 4. So what will my LCD be?
R plus 4, R minus 4.
R plus 4, r minus 4. So what do I need to do to my first expression?
Nothing.
Nothing. She is ready to go. All right, minus, what do I need to do in the back?
Add R minus 4.
Times the r minus 4 and the r minus 4. So I will have 5r minus 20 over my common denominator. All right, now the thing that I will see most people forget is, what do I say every time? I do say that a lot, but on this particular one, you have to subtract both of those terms, okay? If you are subtracting the expression, you're subtracting all terms. So this is going to be r minus 5r plus 20. Over r plus 4, r minus 4. All right, so what's r minus 5r?
Negative 4R.
Negative 4r
Minus
plus 20
Yeah.
over r plus 4, r minus 4. Okay, now this one looks like it would factor, right?
Yes.
But if you factor out a 4 or a negative 4, you'd be left with r plus, you divide it.
I'm sorry, I was thinking of something else.
I know.
5.
Okay, so you'd have an r minus 5 or a negative r plus 5. Either way, is anything going to simplify with an r plus 4 and r minus 4?
No.
No. So don't even bother factoring if you can already see that it's not going to do anything. I can factor out a 4. I can factor out a negative 4. It's not going to impact this overall expression because I'm not going to get either of these. If you know you're not going to get any of your factors in the numerator and the denominator to be alike, don't do it. You're just going in circles. You're wasting time. So my final answer here is going to be negative 4r plus 20 over, what should I get when I multiply this back out?
R squared minus 16.
R squared minus 16, because that's what you factored in the first place.
Instead of doing the extra step and rewriting it, can't you just skip and just write the answer instead of rewriting it?
Yes, if you could go like straight from this one to this one,
Or straight from those two, the two in the black to the green.
that's fine. Yes, I'm just writing out each of the steps. If you can do a little bit of it in your head, that's fine. What are your questions? All right. let's go ahead and do this one. It won't take too long. So the first one's already factored, right?
Yeah.
Remember, this means that I have this expression twice. It's not just y plus, like y squared plus 1 squared. It's not that. You actually have the expression in parentheses written twice times itself, right? So, what's my LCD going to be?
1 minus y, 1 plus y.
Yes, ma'am?
1 minus y, 1 plus y, 1 plus y.
Yeah. I'm actually going to write these as y plus 1, y plus 1. I'd probably, if this was on my personal worksheet, I'd probably factor out a 1 here, a negative 1, I mean, and write it as y minus 1, just because the 1 minus y kind of feels weird. I don't know, but we can leave it like this. That's fine. So what is this expression missing?
A 1 plus y.
A 1 plus y, which is the same thing as a y plus 1, right? Everyone knows those are interchangeable?
Yep.
Okay. So however you feel like writing it, that's what's missing up here. All right, so y times y is y squared. Y times 1 is y. All over that common denominator. I'm going to write it like that. Is that okay with everyone? Just because we're almost out of time. All right, what is the second expression missing from the denominator?
1 plus y, 1 minus, y plus 1.
It has a y plus 1. It has a y plus 1.
1 minus
It's missing the 1 minus y. So I'm going to multiply by 1 minus y over 1 minus y. Now, here I need to double distribute. It's going to be kind of tricky. So we have y times 1, which is y. Then we have minus y squared, because we have y times negative y. Then we'll have plus 2. Then we'll have a minus 2y. All over the common denominator. All right. See if we can get some of this to start coming together. So I am adding, again, we're almost out of time, so just for the sake of time, I'm going to start combining like terms up here. Everyone see that? It's a plus sign, so I'm good to go. What happens to the y squareds?
They go away.
They're gone. But I have y plus y minus 2y, which is gone. So just a 2 over 1 minus y, y plus 1 squared. If you want to multiply the denominator out, usually we do when it's 2 binomials. Honestly, I don't think I would even worry if it's 3 binomials. I'm okay either way. If you wanna double distribute your little heart out, you go for it. I'm okay stopping right there. All right? I'm going to get you your homework before we run out of time. Do you guys have any questions? All right. Summarize your notes on your own. Here comes the homework.